My name is Neil Riley. I'm an architectural technologist and BIM coordinator with ArcDocs. I qualified in 2011 as an architectural technologist, and I've been working with ArcDocs since January this year. Okay, so like I said, this is the sixth webinar, and it's model development methodology. Now, model development methodology is, there's a few things. There's a few things to consider with when you're developing your model, what way you want to develop it, and we're just going to have a quick look, or it's more of a guide. This webinar, it'll take about, I'd say, about a half an hour to go through this a few slides. Then after that, I will actually jump into Revit and show you quickly a basic, very basic model development methodology workflow. Okay. Model development, and I'm going to be at about half one. I'm going to be jumping into a Revit template that we have made, and I'll actually go through most of the stuff that I'm going to be going through now in these slides. So, is BIM just 3D? So BIM is more about 3D. It's also the information that's put in. It's not just the actual 3D representation of an object. And get into that in the next slide. Information timeline and overload. So information timeline, that was introduced here in the first module, the McLeamy curve, and overload basically is overloading your model, putting too much detail or 3D detail into your components. So we'll be looking at that, how a project develops from base template. So we'll look at some best practices, and we'll also look at concept components, placeholders, basically, when you're developing from the start. The complexity of components, we'll have a look at some best practices, like model as little as is required in 3D, and use 2D line work with metadata to beef up your component a bit more with information as opposed to 3D geometry. Controlling graphical display, how your 2D and 3D components are controlled and displayed in Revit. I'll have I'll just brush over that, have a quick look at that. Additional information, a BIM, like in your office, there should be a BIM coordinator or manager. And if you have families that you download off the internet, you probably want your BIM coordinator or manager to vet these families and see if they're of high enough quality to bring into a major project. Okay. So is BIM just about 3D? Just basic kind of outline here. Depending on who you're talking to, here it says there's 6 Ds, as in dimensions, but some people would say there's 7 Ds. Really depends. We're really going to be looking at 1 to 4D or 1 to 3D really, and the rest of them, like the 4D is got to do with time, 5D cost, 6D facilities management. So 1D is just 1 point. 2D is a straight line. 3-dimensional, 3D, you actually have depth and height and width, and 4D is your time, as I said. So depending on what discipline you're in, your workflow may be a little bit different. If you're working towards, let's say, facilities management, but all of this, the costing, the facilities management and timing can and scheduling can be worked into a model. Go on to this. So information timeline, the McLeamy curve. So that was by Patrick McLeamy. This was introduced in the first session, strategic overview of BIM. So I'm just going to just skip over this a little bit quickly. So ability to impact costs. So your time is horizontal, and your effort, the amount of effort and work, is vertical. So cost of a design changes increases obviously as the whole process develops, and the traditional design workflow, when all the information is needed around documentation tender stage, or as much as can be done at that stage. But we're looking to, and people involved in BIM are looking to actually get this traditional workflow, more of the work done at the start, at the actual design stage. So information overload. When an object is sufficiently represented without overkill is something that you need to work on. Like for an example here, this grill here and this grill down here. This one here is more true to the original, but is there any need for these openings? And there most likely isn't. It takes a lot more processing power from the computer to actually draw what's going on behind here, and especially if there's shadows cast in here. That if there was 40 of these around your model, would seriously slow it down. Even with shadows off, it would be just as sufficient. It would and it would have the same metadata within it. It's just the only difference between these two is this one, more work has gone into the actual modeling, and you can see that that's an actual 3D element there. But this down here, this could just be 2D line work on top of this surface here, just to represent what it should be. And that's the way I would go about it. And associated data can often be more useful than detailed geometry. So like I said, the metadata, the actual information is probably going to be a lot more useful than actually a model up here that you spend more time doing the modeling than actually putting the information in. Would be a waste of time or close enough to that. So there's no real need to model something to a very high detail. That would be my take on things anyway. Right. So how a project develops from a base template. So a base template should be developed in-house, and it shouldn't be overloaded with too much components. So if you have a template within your office, it should be minimal. It should have a minimum amount of information in it. It should have basic doors and floors, and I'm saying basic, but it should actually have the word concept before any elements or materials, just so it really jumps out when you're going through your model. So this is actually what I'm going to do at the end of this. I'm going to draw a mass model, put some concept materials and walls and doors, and then swap them for more sophisticated elements. And that's only going to take, I'm not doing this building here, I'm going to do a simplified L-shaped building. So we're going to actually go through this step after this slideshow. Put the word concept before any doors, windows, floors, walls, and materials to define them as a temporary placeholder that you can swap further down the line for more specific elements that have more metadata and a little bit more 3D geometry that relates to its real world counterpart. It's basically what we're getting at there. Level of detail. Now, depending on who you're talking to, level of detail can also mean level of development, or sorry, level of detail. Sorry, level of development here can also, LOD can also be referenced as level of detail. Two of them are different. Level of development, which is basically how far your project has developed from a basic schematic stage, which would be just basic shapes. Okay. Grade 1 and grade 2, concept and defined, the two different terminologies there. So this is grade 0, this one would be grade 1, and this one is grade 2. Okay. So a grade So let me see now. We're on right level of detail or level of development. In Revit, there's a level of detail, and I'll show you that quickly when we jump into Revit. But this phrase here, level of development. So grade 0, schematic, mass, and form study, line diagrams, scheduled and developed to match the briefing requirements of what's needed. Also, basic energy analysis reports can be performed, and different reports can be compared to each other side by side, just at this stage here. So that can be helpful at the start, just to get your right orientation and things like that. Grade 1, which is your concept. So you have your general placeholders, like I was saying. So you'll have placeholder components used to develop the design, and superficial dimensions can be used. Limited materials and component can lead to fast development at this stage. Okay, so you can, if you use basic components, basic materials, it can be a lot less of a burden on your system. Okay, okay, grade 2, which is basically here defined. So this is basically grade 2. After grade 1, you have rough floors. You have a kind of a good idea where you're going with the design. Then with grade 2, you're going to define this and make design decisions. So placeholder elements are swapped for manufacturer-specific objects. Metadata is attached to specific elements, and metadata needs to be typed or pasted in only once and can be scheduled as needed. So when you put information into Revit correctly, you only have to put it in the one time. Okay. So if you have a door and you have, the fire rating of 30 minutes, you can put that in, and then wherever that door is placed, it knows that it's a 30-minute fire rating. Okay, that's I'm getting at there. Grade 3. So grade 3, there's not much of a difference between these two. The only real difference is aesthetic 3D characteristics. So a grade 3 model contains the same amount of metadata as grade 2, but grade 3 differs in 3D representation for higher quality renderings. So renders of grade 2 can be used, but if a higher standard of rendering is needed from Revit, the grade 2 component geometry may be changed for more accurate component geometry, and more complex and realistic materials are used. So that's grade 3 is basically for presentation, but it can have the same information as your grade 2. Okay, and we also have here grade 4 and 5, fabrication and facility management. This can focus on the information relevant to manufacture and assembly, and as-built record with the operation manual. And that's really step grade 4 and 5 and 6. So we're going to skip that and let's have a look at this level of development. So geometry complexity is a critical aspect of pricing and specification in any 3D modeling task, and it's that because of time, labor, and resources needed. So you need a lot less resources for your, let's say you had a huge or a medium-sized project, and there was many different services in it, and if you modeled them to render this level of detail, you wouldn't need to, your computer wouldn't have to be an excellent computer. But this one here, if you had a lot of detail like this all around your model, it could really drag down the performance of that computer, and that would mean you'd have to update, or you'd probably have to get new computers or update your current computers to actually keep up with all this detail. So if a high degree of 3D geometry is required, the computers that you need to be able to handle heavy models if you're detailing to this level here, and the time needed to actually model complex elements at a time as well. So you're talking about time and actual hardware resources. So it does have a big impact on the contracts, okay, that are signed and have to be followed. So complexity of components. We have grade 1, grade 2, and grade 3. This relates to, I'll just go back a few slides. Now this is grade 0, grade 1, and grade 2, okay? Same terminology here. So grade 1, grade 2, and grade 3. So it's going up one step. So the grade 1, this is the concept grade. Just a basic outline, no real information in there, just a rectangle square, or sorry, a rectangle here and a rectangle here, and then a frame around that. And that's good. That's a good placeholder concept element. Then that would be swapped in for a more advanced door that has its information all put within that element. Possibly if it went to render stage, the only thing added in was just a material here at the kicker board down at the bottom. So but it has the same information actually within it. So the only difference here is really an aesthetic one. So controlling graphical display. So this door here, right now, this is where I mentioned level of detail, and we were looking at level of development. Okay, but now we're looking at actual level of detail. So this is view specific control within Revit. Like I said, I'm going to show you level of detail as I'm going through the level of development. Okay, so this door here, here's 3 different representations of this door in fine, medium, and coarse detail. Okay, so coarse, you can see it's simple enough. There's no frames. It's just the openings where the openings happen, and that's in coarse. Then if you put your view into medium level of detail, you have a bit more extra information around on the frame. And then fine level of detail, you have a good bit more information within here. And all this information is generally, okay, it's generally 2D within your actual 3D elements. So 2D elements within your 3D element. So symbolic lines that show you this is roughly where this is where the opening is. Okay, so control that in this family element visibility settings. So family element visibility settings, this is how you control the visibility of your 3D geometry. So see this view specific display in 3D views, and okay, that word there, and your plan, your front, back, left, right. So they're plans and elevations, the plan, front, left, right. Okay, so if I selected all that geometry, 3D geometry, and then went to this dialog, I could switch off all this so that when I'm in plan, that this 3D geometry would not come up here, and this 2D geometry that I drew in, that's a lot less resource heavy on your computer, comes in instead to represent where the opening is. So that's one of the bigger concepts to get there. Detail levels, coarse, medium, and fine. You can actually tell Revit if you want particular elements to appear in coarse, medium, or fine views, or level of detail within that view. Again, I'm going to actually go into Revit and we'll be having a look at that. Okay. Just went over this, and it was is BIM just about 3D? And it's not about 3D. If you remember from the second, I think it was the second seminar, Revit is all about the information. That's what Revit wants. It wants the information so it can be scheduled and used. It's basically, like was mentioned, a database, and then that database is used to draw the drawings or to make the drawings. So it's kind of like a side product that comes out of putting the data in. Okay. Information timeline and overload. So the information timeline, we want to move where the bulk of the work is done in the actual construction and tender stage, to try and get a lot more of that work done in the design stage. And overloading a model or a project with too much detail can be an issue as well. So that's something definitely to keep an eye on. How a project develops from a base template. So as I was saying, you want to have a template in Office, so you're not always template that someone else made and getting it set up the way you want it. You want to set up your own in-house template so that you can work from there and you're confident with what's in it at the start. And like I said, have simple geometry like this chair here. Kind of have that in as a concept. I wouldn't have a chair like this in my template because I wouldn't be sure if I'd be putting like a chair like this in. But this kind of outline, this kind of simple geometry is very good for getting the design ready or getting the design to a certain stage. Okay, the complexity of components. So you don't want to, if something is very has got a lot of detail in it, you don't want to model every single bit of detail if it's not needed. So just model what you need, okay, and any extra bits that you want to add in, just for a look. You want to, if you can't do it in 2D, it'll be a lot easier on your computer. Graphical display, like I said, the levels of detail, the level coarse, medium, and fine level of detail for components within Revit. So that's an important one, controlling graphical display. Okay, and additional information, like I mentioned, about the BIM coordinator. So if you download any families or anything like that, you don't want to bring them in. It may look fantastic, but this actually relates up to overloading a family. If you downloaded a window, a complex window, and it was modeled to, it had everything, the screws, the bolts, hangers, all sorts of hinges, that would be quite a heavy model, and that would be, in my view, too heavy, and it would have to be simplified a good bit before I'd want to have that in a project I was working on. I think that's okay. So I'm just going to jump into this now, and at the end of this example, if you have any questions, just let me know. Okay, so okay, just making sure I can see you all. Can all see me? Just give me 1 sec. Okay. Right. I'm going to open up a basic template here. Okay, and I'm just going to go to first floor. Now I'm just going to skip back to here just to show you what I'm going to do. Showing an outline like this, I'm going to develop it to this stage here and then bring it to this stage here. And I'm going to do all this within one model. So I'm not going to have 3 different models develop up to this stage and then develop another building here. This is going to be one continuous building. Okay, and I know he's just looked at visibility graphics just there the other day, so don't worry about don't worry about the specific things that I'm doing. It's just the overview of the whole model development methodology. That's basically what I'm going to demonstrate. Okay, and I'm going to be doing stuff quite quickly, so there's no need to get worried, because I'm going to be running through this fairly quickly. So what I'm going to do is do a mass. So I'm going to call it building for the time, and I'm going to draw, like I said, an L shape, make it 7 meters or 7 meters 100 in here. Very rough. And that up there, and that's the outline of the building. I'm just going to select that, create form. I'm going to go to a 3D and just have a look, and that's a simple enough outline. I'm just going to make it shaded so I can see a bit better. Okay, so this is quick form there. I'm going to go into an elevation. So here I have ground floor, first floor. I also want a roof floor up here. So I'm just going to finish this mass level. I'm going to bring this up, and I'm just going to make sure that I don't make a structural or a ceiling plan. I just want a floor plan. Okay. The 3.7 meters just above this. Now after making that, you see this level 6. Level 6. I want to call this roof. I like to rename corresponding views. Yep, and you'll see this change to roof as well. There we go. That's handy. Now I want to make these go beyond my building. See the way I grabbed one and drag them all across. Okay. Now I'm going to align. Go. This and this and lock it. So if I go here, change this to 750. Should bring it down just a little bit, and the actual model went down with it. Okay, so now I'm going to go to 3D once more. I'm going to click on the building. I'm going to mass floors, ground floor, first floor, and there we go. The first stage done. It's pretty much done to, let me see, you can just bring it up, model development, and stage here. We're just finishing this stage here. We're after putting the floors in, or our temporary kind of placeholder floors here. Okay, and now just going to go to this view, 3D view, going to rename this grades. Okay, and I'm going to lock this view as well. Lock, because I'm going to save an image of this and call this, call it grade 0. Renderings, double click on that. Okay, I've got an image of grade 0. Go back into my 3D view. Okay, now I'm going to start developing this up to grade 1. So I'm going to start putting my walls. I'm going to have walls on the outside, and then on these walls here, I'm going to have curtain walls. Okay, so I'm just going to go to my mass in the site and wall. List down, I have a few different wall types here. I'm going to use, see the concept here. So this is a template file, and there is some concepts. So I'm going to go with concept 300 here. All I have to do is select that plane or that face, and it adds it in like so. Okay, now I'm going to do the same with floors. I want to add a floor in here. Concept, yep. The whole concept there and there, and create floor. There's a simple floor there. Now I'm going to go back and put a roof on. I'll go with a concept roof. Roof, there we go. Now get rid of my mass, my building mass. there we go, it's off, and that's it off. Oh, I have to switch it back on once more, and just I have to put curtain walls here and here. So I'm just going to wall, drop down to exterior glazing, put it there and there. I'm happy enough to switch the masking off. It's fairly basic. I want to just fix these walls up a little bit and see that the floors jutting out. I want to fix them and the roof. I want to fix them up a little bit. So I'm going to go into my ground floor. I'm going to floor. There we go. And edit boundary. I'm just going to align this to the inside. And click finish. And happy enough with that. I'm going to go to the first floor, do the same. Floor. Oh. Floor 1. Floors. I just want to have one floor mirror. Yeah, now I click edit boundary. I'm just going to, from the outside, bring it back in to the inside. And align it to the inside here. Click finish. A quick look at that in 3D. So, right, that's after bringing it in. You can see these walls are now not actually coming down, but I can fix that fairly easily. I'll just fix this roof first. And I can actually I don't have to go to an actual plan to work on this roof. I can just, if you see this view cube, this is very handy as you get into Revit. So I'm just going to click here on the top. That brings me into an orthographic view. It's orthographic, so it can actually work on the model here. So I'm going to pull these edges in and out if I want, but what I want to do is just align it. So align there with there. There. Fine. Now, just go into my 3D. Yeah, that's grand. Now, I want to select all these walls right around like that. Now, I just hovered over the edge and hit Tab to actually select the chain. Now, I want to go over here and change my base offset to mine. Oops. Again, select all them, change my base offset to minus 300. I know that the concept is 300, and there we go. It's after fixing down there, but it's after not fixing up here. So I'm just going to select all these and top constraint, make that roof, and that should then pop it up. Yeah. So now this is working the way that I want it to work. And I also, no, that's fine actually. Now done the shell of it. Now I'm going to go into my ground floor. I'm going to draw some internal partitions. Click on the wall, change the wall. I want a generic or concept internal partition 100 across here and down here. And I'll just place two or three walls. Now, I'm just going to put some doors in. So because this is a template, when I click on door, I've actually got concept double door and concept single door preloaded in here. So I can just select my single door, and I'm going to place that on this side, flip it, the double door in there, spacebar. And they're off. These are, don't look actually off. I'll go up here. I want these the same distance. So I'm going to annotate a line from the center of that to the edge of here. Actually, I have to do it all in one go. to here to there, and then click equals, and that makes them equals. Well, I can just click on this and I can see that it's 200 away from the edge here, so I need it to be 300. So what I'm after doing is just clicking on this object, and a listening dimension popped up. Okay, and it says 200, and change that to 300. If you look down here after I hit return, the two of them. Okay, so these are this is 300 here to here, and if I click on this and make this 400, it updates on this side as well. Okay, handy thing to know. Do the same thing here, and go to the center, go to the edge, right here, equals. On this now, I could do the same, just type 200, but let's say I wanted it to be 400 from the center of the wall. I'll have to click on this listening dimension and come down to where the actual element is. 400 here, and it makes it 400 here, and it equals it here. That's 400 there. You can do that fairly easy. So I'm gonna just throw in a double door as well. Here, in, and let me see. Right, I think that's fine. I'm gonna go back into my 3D view, and you can see the walls are not actually attached to the underside of this. So I'm going to right click, select all instances in entire project. I know they're just on here. So select them, click attach top to, and this, and now they're all attached to the top of that. And that's what I want. Go back into the ground floor, highlight all these, and copy. And I'll just go into a 3D view and show you what's going to happen. Go in here, and I'm going to, I'll just make it a little bit, there we go. I hit copy, and then paste to selected levels, just the first floor, and that, and there you go. I'm happy enough. That's the same here. I'm going to go into my first floor, instances visible in view, this up to the roof, top offset. Actually, no, I don't want to bring them up to the roof. Select, highlight, select all in view. 3D, are they all? Nope. These here, actually. Patch 2. There. So they're all fitting now. And there's no stairs there. Do something later on. But I'm going to actually save this, or save an image of this. So if I go back to my grades, my massing, and I'm going to save this. Save the project as grade 1. Click OK. So we started off with a grade 0 like that. We developed it up to a grade 1 like this. Okay, so I'm going to go back into a 3D view here. Now I want to start developing this up with some better materials. So if I click on this wall and click this drop down, I don't want to use this exterior block on metal stud or these generic. I want to use some extra things and some more doors. Now I have a file that I made up that I put some extra bits and pieces in. So I'm just going to load it in. Load in, and let me see. Desktop. And let me see. It is this one here. Okay. Warnings that pop up. what I'm doing is actually loading in a wall type, a floor type, some materials, just to bring this model on. So this is grade 1. I'm going to develop this to grade 2 now. So I'm highlighting all these walls again over here to my drop down, and the only model I want to use is this cavity. Loaded. This wasn't here before I loaded in, and that group. So I'm just clicking on this, and now if I deselect, you can see it's after changing that wall type. Okay, now I'm going to do the same for the floor. I want to select the floor here. I can see I have a ground floor. I'll pop that in, and this first floor here, and very handy. If I click on this, actually I'll do it in the ground floor. If I right click, select all instances in entire project, it selects all of this wall type. Okay, so you could have 5 different wall types, and if you select one type, it will only select that type within the whole project. So I've only got one type, so I select walls in the first floor and the ground floor, and I want to change it to a partition that loaded in type F6Q. And you can see it's after, excuse me, it's after widening that. Okay, and I'm also going to click on this door here. I'm going to right click, select all instances in entire project, and change it from concept decorative. Now to I'm after adding a wall that has more information. Well, you can't actually see that information here, that data. So remember I mentioned level of detail? Well, this button down here, level of detail, is what I was talking about. So this level of detail, at the moment, you can see with the white, with the clear swatch there, it's just coarse. So if I want to go to fine, if you keep an eye on the drawing, just click this. It's after that actually relates to this this drawing, or the elements within this drawing. So I'll put it back to coarse. See the way this door here is simple. There's not much information there. We bring it to fine. There's a bit more information there. It really depends on who makes the family, how much information or graphical information is going to be at different levels. There probably won't be much of a change in medium. You can see only there's a tiny little piece of stopper there. So we're after swapping all them in. If we look at it in 3D again, you can see I only put that material on that wall just to make it jump out. So it has changed, just so you could see the change. Has changed, and now I'm just going to put in a revolving door here, and so I'm going to put in a revolving door into this glass, into this curtain wall, sorry. So I'm just going to get through. You see the way it's actually, the floor is actually, you can see it. So I want to add in a spandrel panel along here. So I could go into an elevation, but like I said, this is an orthographic 3D view here that we're looking at. And I can just go to, if I click on back, it actually brings me into what I have selected. I want to zoom out a bit. Extra grid line along here just so I can add some spandrels. So I'm just going to add a grid and add an extra just below there, 400. Happy enough there. Highlight all these, filter, check known panels. So these 5 panels, they're actually clear glass. I'm going to change them to, just while I'm here. And now I'm going to change this panel here to a door. There we go. So load in another door, another more complicated door here, but I won't. And now I'm just going to go to my 3D grades that I was using, and you can see that all updated there. I'm going to do one more thing just to make it jump out. surface, just a quick little topo surface at 0. I want it all be at 0. There we go. And also I want to finish that and then put a subregion. Finish that. Now look at that in 3D. Then we have a bit of development there. Go back into my grades and now I'll save this as grade 2. Right, now I'm going to go to a sheet. And these images are a little bit big for going onto this, all of them. So I'm just going to that sheet. So grade 1, here we have grade 1, grade 2, 0, grade 1, and now grade 2. Sorry. So you can see that should be a little bit bigger, but anyway, you see that we started with a massing study. We could have scheduled out floor areas, floor volumes, if we wanted to actually see how much of a rough area we would be getting. And once you get to a rough figure that you're happy with, you develop it up to a certain level that would be agreed, and then when you start making more definitive design decisions, you're into your grade 2 development stage. So very quick example of working through a model development methodology. And let me see, is there anything? That's it. So I plan the detail. Oh, okay, so I'm just going to unmute everyone. So if you have now, we're going to be going over wall creation, floor creation, and all of that over the next few weeks. So I was just doing this, just built it up fairly quickly, just to show you that you can do a quick mock-up fairly quickly of an idea that you have or that you want to test out. So if you have any questions, just type them in and I'll answer it.